Welcome and hello. This is a video exercise using the HEC-RAS controller. I'm titling this one Basic Worksheet Interface because in this exercise, we're going to build a basic user interface in a Microsoft Excel worksheet, which is what you're seeing on the screen right here. This is our final results. I'll go ahead and do a quick demo of what we're going to be building in this exercise from scratch. That way you can have a little bit of a teaser as to what the final product is going to look like. So we have some input data up here, and then we have our results down here. All we need to do is select a flow rate in CFS and a river station, one of these cross sections that were listed, and then the RAS controller is going to look up the results from a 1D steady flow simulation and return them in these fields. Results, these are just random variables that I selected. Some of the more common variables, I presume: water surface elevation, energy grade line, normal depth, and so on. So let's just do a quick demo now, and then let's actually start building out the RAS model and the controller code to build what we're seeing on the screen right here. So for a flow rate, I'll just select 2000 CFS. We'll select the cross section at river station 600, and boom, here are our results. That's what we're going to be building in this exercise. So if you're interested in doing something like that and learning more about the HEC-RAS controller, this is the right video for you. Okay, so enough of a teaser. Let's go ahead and get to work. This is a different Excel file that I'm going to use. So my first step is just to go up to the File menu and then New Workbook. So here it is. I'm actually going to save this as well. So save as, and I'm going to save it as a .xlsm file, and I'm going to call it controller.xlsm. Then I'll put it, how about just on my desktop for now, is good, and save. Okay, so that's good. I'm going to call this worksheet EX4 just because the code that I'm going to be pasting in says EX4 on it. Just to make things simple, I'm going to copy in some of the template code right here into my controller, which, let's see, what cell was that on? Star.22. So boom, right there. If you want to use the R1C1 cell referencing, which I have ones across, like 1, 2, 3, 4 numbers across the columns, you can do that by going up to File and then click on Options. If you don't see options in the left panel, click on More, and then Options is right there. And then you're going to want to click on Formulas, and then toggle this R1C1 reference style checkbox on or off. But for this exercise, I'm going to keep it on. All right, so there's that. I'm going to zoom in. Okay, and then let's go ahead and paste in the variable IDs as well. So 2 for water surface elevation, 3 for energy grade line, and so on. All right, so that's enough for the Excel. I'm going to go ahead and save that. Let's head over to HEC-RAS and build out a simple model, which once run will have output data that we can read in for our results. All right, so to do that, let's go ahead and minimize that. There's some code. We're going to look at that later. We've got HEC-RAS up on the screen here. Let's go File, New Project, then navigate to where you want to save your project to. Put it in my project directory. We'll call this Project 2 and .prj, and OK. We're going to be using US customary units. Let's open up the geometric data editor and then start sketching in a river reach. So boom, there's my river reach. I'm going to call it River A and Reach 1. By default, that's going to be a River ID 1 and Reach ID 1. So we'll be referencing that a little bit later. Click on Cross Sections now, and then let's start with creating a new cross section at River Station 0. So click OK there. Now we need to provide the station elevation data. So let's go ahead and paste in some numbers I have prepared. And then boom, here is my cross section. So for the downstream distance, it'll be 0. The Manning's N value, I'll just make up some numbers. And then the left and right bank station looks like it's going to be 40 and 100. So let's save that. Now I'm going to make a copy. I'm going to create a upstream cross section at river station 1000. So same river, same reach, 1000, and OK. And I'm going to come back and change the elevation data a little bit later. I do need to update the distance to the downstream cross section that is currently 1000. Apply, and let me close that. Okay, boom, that looks good. I'm going to interpolate and add intermediate cross sections every 200 feet. So tools, cross section within reach. This is my reach. That looks good. I'll type in 200, interpolate, and close. Okay, now I'm going to go back to the cross-section data editor and update the elevation values. So this is good at river station 0. At river station 200, I have some different numbers that I'm going to just paste into place there and then save, and then go up to the next cross section, which is river station 400, and slightly higher numbers, but not too extreme. We can take a look at the profile view once we're all done with this. So this is the elevation values at river station 600, and then two more here. Here is river station 800, and then the last one is at the top of the reach, the cross section at river station 1000. Apply data, plot, and then plot profile. Okay. So you can see we have this profile that goes downstream, of course. It looks good. That's all we need to do for our geometry data. So I'm going to close the cross section editor, save geometry data. I'll just call this base. It's going to be our only geometry. So that's good right there. Next, I'm going to enter some flow data. This is going to be steady flow. So I'm going to come up to edit, steady flow data. The slope was about 1%, a little bit less. So for the boundary condition, we'll click on downstream. I assume this will be subcritical. Well, actually, yeah, probably. I'm going to click on normal depth, and then I'll just type in 0.01. Maybe a little bit of an overestimation, but close enough. And then for upstream, let's just be safe. I'll also type in 0.01. Okay. And OK. Now, by default, we only have one flow profile. I'm going to change that to 5. So now I have 5 different values here. And what I'm going to do is vary the flow rate for the 5 profiles between 1,000 up to 12,000. So I'm going to use 1,000, 2,000, 5,000, 8,000, and 1,000. Also, instead of PF1 to PF5, I'm going to just copy the number itself of the flow in CFS as the profile name. So to do that, I'm just going to go up to Options, Profile Names, and then right here is where I make those edits. I'm going to start by just deleting the existing names and then type in the same numbers as before. So pretty tedious here, but we only have 5, so it's not too bad. 12,000. Okay, so click OK. These labels have updated right here in the table, and that'll also make it easy for us when we look at results, either in a plot or in a table, that the legend will display the actual number of the flow rate in CFS. All right, so next we're ready to actually run the model. Let me save this data as well. I'm going to just call it base. I know that's not as descriptive as it could be, but good enough. I'm going to go up to run and then steady flow analysis. And then I'm going to click on mixed because it may become supercritical, but I'm not sure. So that's the safe way to go. We have our base geometry file, our base steady flow file. So just to be consistent, I'll call this plan base. It's going to be our only plan. So there's no reason to be too particular about the naming. And boom. All right. We're ready to run the simulation. So I'll click on compute. That finished up. Let's go ahead and take a look at some results now. I'm going to go up to view and then cross sections. All right, so let's take a look at cross section at river station 0 right here. Looks like this is the water surface elevation for the 1,000 CFS flow, or our first profile. I'm going to add all 5 of the profiles in this view and then toggle between the different views. So you can do that by going up to options and then profiles, and then just select all, OK, and boom. Now this light blue coloration only appears for the first profile apparently, but you can see the water surface elevation of 2,000, 5,000, 8,000, and 12,000. It's highlighted in red when I click that record over here in the legend. This is just the cross section at river station 0 though. So if we toggle up to river station 200, 400, 600, 800, and finally 1,000. All right. So this gives us enough data to work with. We now have output files that have been generated in our project directory for this HEC-RAS project as a result of running the model. And now we can get started with our VBA code. All right, so I'm just going to leave this open for now. Before I run the code, I do need to close it because the code is going to open up the project and close it a number of times, but we can take care of that later. All right, back to our HEC-RAS controller, our controller.xlsm file. The first thing I want to do is make sure I have a developer tab. Actually, I'm going to double click on the tabs so that they stay down permanently. Another way to do that is just to come down to this drop box and say show tabs only, full screen mode, or always show ribbon. Kind of like the toggle between show ribbon or not show ribbon based on what I'm doing. That's not important. If you don't see the developer tab, go to File and then go to Options again. You might have to click on More and then click on Custom Ribbon over here on the left, and then make sure you have the developer checkbox checked on. Click OK, and then boom, you'll be up to speed with where I'm at right now. Click on Visual Basic, and then, okay, so this is code from a different project. Here is the current project, I believe. I need to make this Project Explorer window a little wider. Yes, controller.xlsm. All I have is sheet 1. It's named EX4. Yeah, no modules, nothing else fancy like I do in some of my other files here. Let's go ahead and just collapse those other files. All right. I'm going to write all my code in this sheet 1, which I've labeled EX4. So just double click that and boom, we're ready to rock and roll. Also, one thing to mention is click on Tools and References. Double check that you have the HEC-RAS reference included. I do not, but it's right here. And yes, this is the version I want, 6.6. So I'm going to check that checkbox and click OK. Now, your HEC-RAS reference may not be right at the top. I'm not sure why it is at the top, to be honest, because it's not checked on, but it is alphabetical, this list here. So just scroll down to the H's. You'll see, I'll just go there now. Here we go. So here are my different versions of HEC-RAS that I just haven't used or haven't used in a while. Just make sure you have one HEC-RAS reference checked on, click OK, and now we're ready to go in with our HEC-RAS controller code. I am going to start by pasting in all the code. So that there's kind of a lot here to talk about. There's one subroutine called get results, which goes down to here. And then after that, I've got a separate function I wrote, which is just to get the profile ID. And then finally, this little function here serves as a listener just for the worksheet. In fact, this is probably a good place to start. And then we'll talk about the other parts of the code. So what this private sub worksheet change is doing, this is a reserved variable. You can see change up here in this activation. So yeah, it's not the name of the function. It's a subroutine and it's called worksheet change. And what's happening is whenever anything on this particular worksheet we're selected on that the code is in, which is worksheet 1 or EX4, changes, this runs. So what I'm doing is I'm basically checking to see if the value in cell 3.3 or cell 3.4, that's row 3, column 3, or row 4, column 3, changes. And if it does, run this get results subroutine. So that's all that happens right here. Obviously, you can add more code to check for changes in different cells in this subroutine, but this is all I really need it for. So yeah, what we're doing in the Excel now is checking these two fields. And if they change, then we're going to need to run the script, or at least check to see if the script needs to be run, because we need to have values that are valid in both of these fields for the results to actually calculate and return to the worksheet successfully. In fact, while I'm here, let me go ahead and add my units for flow. So that's going to be in CFS. The river station really won't have units, but one thing I want to do is add a drop down so we can select the different flow rates and the different river stations that we have cross-section data for. So to do that, I'm just going to go off to the side real quick, and I'm going to create a list of values that we want in those drop downs. So I'm going to just call this drop down values, and then I'll say flow, and then I'll call this river station for the two different drop downs. Okay, I don't need units per se, but I know that the flow rates range from 1,000, 2,000, no, it's 5,000 is next, and then 8,000 and 12,000. So with these values, I can create a drop down here. I'm going to just click on the cell that I want to create the drop down in, and click on data, and then click on data tools, data validation. And now what we're doing is for this target cell, we're going to allow a list, and then the source of that list is going to be right over here, these 5 values. So click on this button here for the source, highlight that list. This is going to be the list that we're going to see in the dropdown in this particular order. So then click OK, and boom, that's all we need to do to create a dropdown. So we can select 8,000 or 2,000 or whatever the number. We can also delete it if we want. All right, so we're going to do the same thing here with River Station. The river stations, I'm actually going to start at the top, which was 1,000. And then below that was 800, 600, 400, 200, and 0. So just as before, I'm going to click on the cell that I want to create a dropdown for, which is right here, River Station, Data Tools, and then Data Validation. Okay, so we want to select a list, which is here, and then the source of that list will be right here, and boom, and okay. So then our list of river stations are right here. So ideally, once we're done with the code, we should be able to, oh yeah, so it's running right now. It's probably lost because I need to update a number of things, such as the project it's looking for. But yeah, it's a little bit lost. Okay, so when something like this happens, boy, I should have saved before I did that. Oh, okay, so what happened is I got a warning. It can't find the project. That's fairly safe. So let me just close that. I'm just going to hit end. I don't care about debugging. There's a lot of things I should have done. In fact, I'm going to go ahead and close HEC RAS and not test it. Let's go back to Excel. The last other thing I wanted to mention here is usually you're not going to want to see this in your user interface. This is just background data. So one thing you could do is just right click and hide, or you could put all of your data on a different worksheet. There's a lot of ways to sort of make things look a little bit nicer and user friendly, but hiding it is fine for now. We know there's something between columns 6 and 10, and that is the data that is populating these two drop downs. So I'm going to delete that, delete that. We'll come back and test it a little bit later. Let's go back to our code. So developer tab, Visual Basic. We know what this does. Let's take a look at that results subroutine, which will be invoked as soon as there's a change in either of these two cells. So that is at the top right here. The first thing I'm doing is I'm clearing out the results. So if you're using the R1C1 cell reference style, this is how to clear the contents for column 3 for rows 7 through 14. The me right here just refers to the worksheet. So you can't use the keyword me within a module, but you can within a worksheet. Okay, next up, we're going to check those two cells, the two input values, which is the flow and the river station, these two 3.3 and 4.3. And what we're doing in this block of code is just basically testing if it's empty or not. So if the flow and the river station are, if either of them are empty, nothing's going to happen. It's just going to clear the results, and then this whole subroutine is done. However, if both of them are populated with values, which have to be valid values because we created that dropdown, then it's going to run the rest of the code. So we're testing those values as a string because I'm reading them in as a string here, but I'm also getting them as long, the long integer variable type, because we're going to be using the flow and the river station variable a little bit later in this script. Okay, so let me scroll down a little bit here. What we're doing here is we're opening up the project, and one change I need to make is call this project 2. So that should work. We are creating this con is the name of our RAS controller object, and then after that we can reference that object using the con period. After that, let's see, we're getting the data and then we're retrieving the variable of interest and then we're printing that variable to the worksheet. So I'm going to describe it sort of working backwards. This line right here is on dot, here's the function output underscore node output. And then it takes in a number of parameters and it's ultimately going to assign var, this variable, as the value, whether that is a 45 for the number for the water surface elevation, or it's a 0.8 for the fluid number. This var is returned from this function on this line. In the very next line, var is written into the worksheet in a specific row in column 3. So the rows are going to be ranging from 7 to 14. Those are these rows right here, column 3, row 7 down to row 14. So let's go back to this. Yes. And then also what we need to talk about is the different parameters right here. So these are the input terms that are being fed to this output node output function. There's the river ID, that's going to be 1. And then there's the reach ID, also a long. equal to 1. The node ID is also a long variable, and we are getting that using the output underscore get nodes function right here, where we pass the river and the reach, and then the river station number as a string. So this is reading in the number from the Excel, which is right here, which is row 4, column 3, and then we're converting it to a string. RS is something that we assigned way up here, so that's already done. Don't need to do that twice. UPDN is the fourth parameter. It's a long, but we're not using it for cross sections. And then profile ID takes a little bit of a description. It is a long integer, and it is our profiles are the 5 different flow profiles. So 1,000, 2,000, 5,000, 8,000, and 12,000. And those are going to be 1, 2, 3, 4, and 5. But we don't know that. We can't just guess it. So what we're doing is we're going to pass this function that I wrote called get profile ID. We're going to pass it the HEC-RAS controller, the river ID, which is 1, and then we're going to pass it the flow value, which is also a long. Now, flow is what we selected from the dropdown in the user interface right here. So that's going to be one of these 5 values. And then let's see, back to Visual Basic. Let me scroll down here. Okay. This get profile ID is going to return a 1, 2, 3, 4, or 5 because it's going to, let's see, let me just take a look at that function. Yeah, here it is right here. Get profile ID. Here is the on HEC-RAS controller, river ID as a long, and profile name. And what we're going to be doing is getting all the profiles for this particular river ID, and it's going to assign them to this profile names array. Now, this is a subroutine, but it's still passing by reference. So this profile names array will be populated with the different names. And then what we're doing is just going to loop through the names. And as soon as we find a match where the profile name that we're passing in equals one of the profile names from the array it's looked up for that particular river, then it's considered a match. And we're going to return the variable I, which, like I said, is going to be 1, 2, 3, 4, or 5, or however many profiles that you have. And then finally, end function. If there's no match for whatever reason, then the loop would continue and terminate, and then I'm just going to return this -1. So hopefully that doesn't happen, but it would be one way for me to test and debug if get profile ID returns -1. So that is the explanation on profile ID. And then variable ID, var ID, that's the last of the 6 parameters that we're passing into the output underscore node output function. What that is assigned right here. So I don't know if you noticed in the worksheet, but over to the right in this column 4 here, I've added the variable ID that's associated with each of these parameters. Now the HEC-RAS controller has hundreds of different variables. These are the ones I selected because I just think that they are a little bit more common. So 2 is water surface elevation, 3 is energy grade line, 4 is the depth. I have made them grayed out because they're just not quite as important, but I still wanted to see them and remember that they're there. And of course, it makes it easier to change the number if I wanted to change the variable. But yeah, that's just one way to do it. I could hide it just like I hid the drop down values, but let's leave them right there as is. All right, so I think that's about it. I think we're ready to test now. I'm going to go ahead and save this and then back to Excel. So let's go ahead and make a selection. Let's go with the flow rate of 1000 CFS, river station 1000. So it's running, and let's see here. So unable to locate the project file. 1 second. So click on debug. Okay. Okay, off camera, I figured out what the problem was, you guys. And I want to actually take you through a quick step on debugging as well. So the first thing I did, and I'm not sure why this happens, but using the shortcut to the path right here wasn't working. So I just pasted in the actual full path written out to the project file. So that was one thing I did. And then after that, well, it's still getting an error message. So what I did is I put a breakpoint right here where it's calling this output underscore node output so I could inspect these variables. So let's save and then Excel. And then let's go ahead and just change this right here. Doesn't really matter which one. Okay, so it hit the breakpoint. It hasn't executed this line yet that's highlighted in yellow, but it's about to. And I can just mouse over the different variables to see what the value is. Or I could use a watch logic or open up a separate watch window. But one of the quicker ways is to just mouse over the individual variables. So here we see river ID is 1, reach ID is 1, node ID is 2. Everything looks good so far. Up, down equals -1. That's fine. Profile ID is 1. Yeah, and then variable ID is 0. So that's a problem. The variable ID should be one of these values here. So for row 7, it should be 2. For row 8, it should be 3. Let's go ahead and see which row it's on. So if I hover over row, it says 7. So the value should be 2. And then boom, here's the problem. I'm actually referencing column 5 instead of column 4. So I was being a little bit lazy when I was setting up my spreadsheet. I can change this to a 4 and it should work. Or what I could do is, hold on, let me reset to terminate the execution and then save, go back to Excel. I'm just going to move these values over a column to column 5, which is where I should have put them in the first place. So let's go ahead and cut and paste. In fact, I should have included units anyway. So water surface elevation is feet. That's going to be the same for EGL and depth. Channel invert is also feet. Flow area is going to be feet squared. And then velocity is going to be feet per second. Fluid number is unitless. Width is also feet. So there's that. Okay, let me go ahead and make the feet squared an actual superscript. So format cells, superscript, and boom. Okay, shouldn't have that problem again. Let's go ahead and see if that works. So let me save this if I haven't already. And then let's go ahead and make a change here. That's what I'm talking about. All right, so we have numbers, we have results. We'll take a look at the results in just a minute, but I do want to modify the number of decimal places. We don't need to see the water surface elevation to the nearest 10,000th of a foot, but maybe the nearest 100th of a foot would be satisfactory. So that looks good right there. Let's do the same thing for these. All right, so I went ahead and modified the number of decimal places for each of these results. That looks good. Now let's go ahead and test it. Let's make sure, just a ballpark test to make sure the results we're seeing on the screen actually make sense and coincide with what we would expect to see. So let's start with a flow rate of 1,000, which is the lowest of the flow rates. And then for river station, let's go ahead and start it at the top of the reach, which is cross-section river station 1,000. Now what I'm going to do is change the river station one cross-section at a time all the way down to 0. And let's observe the water surface elevation, energy grade line, and channel invert, which should all be decreasing. So we have 41, 42, and 37. Let's go down to the next cross section at 800. Now we're looking at 40.3, 40.9, and 35.2. That checks out, just making sure that it's returning the correct results. 600, 38, 39, 34.3. Okay, the cross section at River Station 400, 37, 38, and 33. So it looks like this is working correctly. Let's just go all the way down to the bottom now, 34, 35, and 30 for those three different values we would expect to decrease as the river station decreases. All right, while we're down here at River Station 0, now what I want to do is increase the flow rate from 1,000 up to 12,000 at one profile at a time. And what we should expect from that is an increase in a few things, such as the depth, the flow area, the velocity, probably the fluid number as well, and definitely the top width. So let's go ahead and do that. In fact, those are too many things to think about. So I'm just going to focus on how about the depth and the velocity. So 4.1 and 7.6. Let's increase the, flow rate now to 2,000. Now we're up to 5.9 and 9.3 for depth and velocity. And I trust the other numbers also increased, but I can only think about so many things at once. All right, next up is 5,000 CFS. 9 feet is the depth, and the velocity is up to 12 feet per second. 8,000 CFS, the depth is 11 feet, the velocity is 13 feet per second. And finally, the highest flow rate of 12,000 CFS, looks like we're supercritical now. That is 13.2 feet of depth and a velocity over 14 feet per second. All right, well, that is it for this exercise. What we did was create a simple 1D steady flow model in HEC RAS. Then we came over here to the controller and built a simple user interface within a Microsoft Excel worksheet where we had a couple input values and once selected would return results from our HEC RAS model.